Hello, my name is Barbara Andrews, and in this session, we'll explore how to manage prompts for agents. Imagine your team has built an AI agent that works well today, but over time, prompts change, new use cases appear, and multiple team members start tweaking instructions. Without structure, those prompt changes quickly become hard to track, test, or reproduce. That's where managing prompts with GitHub in Microsoft Foundry becomes so powerful. In this section, you'll see how to treat prompts like production code, versioned, reviewed, and improved through a structured workflow. By integrating GitHub with Microsoft Foundry, teams can collaborate on prompt design, track changes over time, and safely evolve AI agents while maintaining consistency, traceability, and control across environments. Here we see a key Gen AI Ops principle. Prompts should be treated like production code because even a single word changed in a prompt can alter an AI agent's behavior for every request. Teams need version control, testing, and a review process just like software development. Practices such as keeping prompts in source control, using pull requests for reviews, testing in development environments, and maintaining the ability to roll back ensures changes remain transparent and safe. For example, imagine a customer support AI agent where a developer modifies one prompt to improve tone. Without version control, that change might accidentally degrade troubleshooting accuracy for thousands of users. With Get-based prompt management, the change is reviewed, tested, and if needed, rolled back. Now let's consider managing Foundry agents and prompts like versioned software. An agent trail guide combines a model, GPT 4.1, system instructions, and tool integrations such as a weather API or a trail database. As the project matures, the agent improves through prompt versions, starting with simple functionality, finding trails and safety advice, then adding context and personalization, and eventually reaching a production-grade prompt with structured guidance and safety checks. Imagine a hiking assistant agent helping users choose safe trails. Early versions just suggest routes. Later versions personalize for skill level. And the final production version adds safety guidance and fallback options. The key operational pattern is storing prompts in version-controlled files like prompt.txt, while Python script agent.py deploys or updates the agent in Foundry. Now let's explore a bit on how to structure a GitHub repository so prompts and agent code stay organized and version controlled. System prompts are stored as simple text or markdown files. Configuration and metadata live in YAML or JSON, and dynamic prompt logic or templates can be handled in Python or Jinja. The example project groups a trail guide agent's deployment script and version prompt files in one folder, making it easy to track how prompts evolve from version 1 to version 3. Why does this matter? Because clear structure prevents prompt chaos. Imagine updating a travel guide AI agent version prompts version 1, 2, and 3, and let you test improvements, compare behavior, and roll it back if changes degrade responses. Gen AI Ops applies software engineering discipline to prompt development. Prompts are first experimented with and tested in development, then promoted through a controlled Git workflow, branch, test, review, and merge, before reaching production. We separate development and production to reduce risks, so experimentation happens safely before anything reaches users. Branch naming, making intent clear, and the workflow requires teams to test locally, document results, and request a review, ensuring only validated prompts reach deployment. For instance, a company updating a customer support AI agent system prompt, developers can test a new version in a development branch, validate the responses, and then submit a pull request so users only interact with prompts that have already been reviewed and tested, avoiding unexpected changes in behavior. In this demo, we're going to step into the chat playground, where generative AI moves from theory to hands-on experimentation. This is where you can interact with a deployed model or agents in real time, testing prompts, adjusting parameters, and immediately seeing how changes affect responses. You'll explore how to prompt design, system instructions, and model configuration influences quality, consistency, and behavior, which is foundational for Gen AI Ops. The chat playground is a safe, fast feedback loop for improving generative AI before it ever reaches users, and it directly maps to our AI-300 skills around evaluation, optimization, and operational readiness for generative AI solutions. Before an AI agent is versioned, deployed, or connected to tools, there's a critical step that often gets skipped: validating how the model actually behaves. In this demo, I'm using Azure AI Foundry's Chat Playground as a pre-agent, pre-SDK validation environment. This is an easy way to test and refine system instructions, evaluate consistency, and understand model trade-offs without writing code. What I'm doing here maps directly to agent design and prompt versioning, starting with a basic prompt, and then I'm going to strengthen it through some iterations and try to identify a version that's stable enough to become part of a versioned agent later. That validated prompt can be stored, versioned, and deployed through the SDK, and it all starts here by shaping and validating behavior early. The goal here isn't to build an app, it's to reduce risk and make better agents and prompt decisions up front. Think of this demo as the step before the prompt becomes a versioned agent in Foundry. So what I'm going to do is I'm going to start off by first creating a new deployment and kind of showing you some of that process and how it works here. And you may know that a deployment is how you operationalize a model in Azure into a managed scalable endpoint that you can test, tune, and use consistently. So if we click on the new deployment here, you will see that there are two options. The base model is letting you do a little bit of everything. Well, then the finely tuned model, it's really going to focus on one thing and do it really well and consistently. So I'm going to choose the base model so we can see what's available there. A lot of models in here, and you can use this to kind of test this out. It'll take a moment to show it up. And I'm going to see what we have for GPT Mini, GPT-5.4 Mini here also. This is really the most used model that we have because it does deliver the best quality at cost ratio for everyday workloads. So that's a really good option, and we're going to choose that option. And there are other options here, though. There's that Nano, and you can click on a lot of these. And when you click on them, it will tell you a little bit about what kind of work it does, the task it works best with. And you can also see its capabilities and use cases and pricing. So it gives you a lot of information right from this one screen. But the Nano is usually for very high volume, simple tasks, maybe for classification and extraction tests that you want to work with. And then there's that GPT-5.4 Pro, and another one here, the 5-4. Both of these are really for complex or high stakes reasoning. But I do want to draw your attention to the new option that you might find helpful. This is the model router. This automatically routes each request to the best model based on cost, latency, and complexity. And you can see it here as we move down. It supports all sorts of models, and this could be very helpful. So maybe considering using the first model router first, and then going in and maybe optimizing your prompt second, and then only pay really for the bigger models when the task truly demands it. So some of these things you can consider as you go through. For an example, we can simply use that GPT 5.4 mini, and this one works really well for what we'd like to do. So what I'm going to do is I'm going to confirm this, and once it's confirmed, what happens is it automatically puts it here in deployment. And I did create one earlier, so I'm going to use the one that I used earlier. So remember, all you need to do is hit cancel. I'm going to come out of that. And then now what I can do is I can use that deployed one. Notice I don't have instructions inside this, so notice that I don't have anything in chat history, and I'm going to clear it out just to kind of start things up. Notice there's a spot for instructions. Notice you can add parameters and additional sections to this. So you can give it examples and a little bit more, and you can actually add a little bit more here. And then down here, you can test it. And there's little sample prompts I can use here that have been created here with it. So what I'm going to note too is that this playground has been optimized for very short feedback loops. So any changes that you do to the instructions here, and when you run the prompt again, once you've applied it, so you can add in, make changes here, and it will affect the behavior immediately for your test on the right. So you might be thinking, what does this really mean? Well, what you need to think about is that most of Gen AI quality problems aren't because of the model being bad. They are essentially unclear instructions, vague expectations, or assumptions that we've never tested. So this is really the playground where we can test that out. So what we're going to do is we're going to test out first by putting some instructions into this model. And I have some instructions here that I'm going to paste in. And I'm going to make this fairly basic. And I'm going to say that you are an AI assistant that helps people find information. And notice that it prompts me to save it. So I'm going to go ahead and update that and save it there. And now once I do that, what's going to happen is I'm going to go through a little bit more here in our chat. So it's very basic instructions, but that's a good starting point here. And I'm intentionally leaving it broad. So what it will do, and I'm going to give it the model a little bit of freedom to respond. But this is what I'm going to ask it, is kind of keeping it with our theme here of the class of the hiking model. And I'm going to go in and I'm going to tell it I'm new to hiking. What gear should I bring for a half-day spring hike? Now, this is a reasonable question, and we're telling it, so it's thinking through, and it actually does a pretty good job. Just first out with this notice, it's giving us some of the essentials: sturdy hiking shoes or trail runners, telling us to bring water, snacks, about a small backpack, sun protection, a lot of good stuff in here. Headlamp in case you might stay a little longer than you plan, things that are nice to have. So this actually is a pretty good response to it. It's a reasonable option here. A result it's giving us back is pretty reasonable from the simple instructions. But it may not be as predictable as we'd like it to be, especially if we have many users asking the same question, and we may get back different style of responses to this. We might also want to give it a little bit more of instructions on how we want it to answer, like what we're going to tell it to do is going to create this in one prompt. I'm going to see what it does with this next one, and then I'm going to give it a little bit more instruction, because the instruction is really how I can control the answer. So what we will do is we'll add this prompt in here, and we want to find out a little bit more about the hiking condition here. So let me add that prompt in. So is a steep trail okay for beginners if the weather is cold and windy? Now I can tell you might be, without asking the model, that's probably not a good idea, but this question is going to give us its best option here. And it does tell us that it's a little riskier. And it's giving the best option, and we can still want to try it out. We can, things to consider, it's telling us here also. So it's actually pretty good too. I think the response is pretty nice here also. But what will happen with this is, again, when we have multiple people asking it similar questions, what we want to do is a consistent answer. So we can benefit from working with these instructions. And that's what I'm going to do right now. I'm going to add these in now, the instructions that we have. And we didn't add these earlier, so I'm going to add them in now. And we've gone with something a little bit more detailed now. And this is just enough. Notice we're telling it you're an outdoor trail assistant for beginners and intermediate hikers. Here's some of the rules. Start with a concise recommendation, then provide 3 short bullets. Why, what to bring, watch out for, and tell us if you're uncertain about the answer. And if you don't know, you need to say you don't know. And then don't invent trail or weather conditions, and keep responses under 120 words. And so what I'm going to do, this is, kind of a new option here that we've added in, making it more consistent. And this is really what we're trying to do, is just get it to be more consistent in its responses. So what I'm going to do is I'm going to ask it another question here. And actually, I might go back to the ones we had right here to see if we get different answers than those. And I'm going to try this again. I'm new at hiking. And actually, I'm going to go ahead and apply the changes there. And then let me wipe out that first chat. And then I'm going to ask it that same question. So new instructions. Let's see what it does with that same question again. So this is going to be 120 words here. And as you can see, it's very short. So bringing in the basics, it answers why, what to bring, what to watch out for. And so we have more control over it, as you can tell. And I'm going to ask it that question we gave it earlier about the steep trail and whether that was acceptable for beginners to do in windy conditions. So we'll ask it that question again, and we may ask it a few more times. But the idea here with our model is we're really trying to control and make its response consistent to what we want. So that is the idea here. And with these instructions we ran, you can see that some of these things, the responses are different, they're shorter. And so I'm hoping you see some of the benefits first, using the model, and then being able to give it instructions. And then the prompt is key, as you know. So we can see with clearer instructions, we get consistency. And so it's also running faster. We improve the quality without code or having to redeploy. And then we also, because we're using that GPT 5.4 mini, this is going to hopefully balance for us the quality and efficiency along with the cost. So any model that you choose, you have to look at the trade-offs. And at this point, you might be asking, maybe I should try out different models. Maybe what I want to do is I want to work with, different models that are out there, maybe ones that are faster, more optimal. But again, what we want to try to do here is optimize the prompt first, then evaluate whether a different model is actually necessary. So that's really what we're trying to do. And many teams jump into bigger models when the real issue is unclear instructions. So really the benefit here is the instructions. What instructions are we giving it? And again, we could add even more information down here, safety systems, examples, variables. You can add more things for it to consider here to generate a system prompt for us. That's a good one. There's more that we could do, we could add here, but I think you kind of get it so far with our example here, introducing the chat playground. So what we've done here is intentionally simple, but it's also foundational. Anytime we use chat playground, we're going to validate how a model behaves. That's what it does, how it responds to ambiguity, and how small changes to system instructions dramatically improve consistency and safety. This is the step that enables everything that comes next. Version prompts, Foundry agents, tool integrations, and SDK deployments. Once a prompt behaves predictively, it can be promoted into a versioned agent, which is our goal. It can be stored alongside code and reused with confidence. Whether the agent later calls APIs, Azure ML models, or other enterprise services. So the key takeaway is great AI systems aren't built by starting with deployment. They're built by validating behavior early. And that's the mindset that this course is designed to develop. So I hope you enjoyed this, and I hope to see you in our next demo. Imagine building an AI agent and realizing that small prompt changes can dramatically change how the agent behaves. Without a systematic approach, it's hard to know whether a new version actually improves the agent or just changes it. This exercise is about fixing that problem. In this lab, you'll learn how to create and compare multiple versions of an AI agent in Microsoft Foundry. You'll deploy different versions of a trail guide agent. You'll use Python to test variations in system prompts and evaluate the results with automated tests. The goal is to practice a key Gen AI Ops skill, iterating on prompt and agent versions in a controlled, measurable way, so that you can confidently improve agent behavior instead of relying on guesswork. Now it's time for our knowledge check. Question 1. In a proper prompt workflow, what should happen before a prompt change reaches production? Answer: changes should be tested in development, validated in staging, reviewed by the team, and then deployed with monitoring. Question 2. What do Git tags provide for agent deployments? Answer: they create a traceable relationship between repository versions and deployed agents, simplifying debugging and rollback. You've now seen how Gen AI Ops brings discipline, safety, and collaboration to prompt and agent development by managing prompts in GitHub, versioning agent behavior, and using structured workflows for testing, review, and deployment. Teams replace ad hoc prompt tweaks with controlled, able to audit information that's evolving. This is a shift from experimenting with prompts to operating agents. Every change is intentional, measurable, and reversible. With prompt management, playground testing, and version deployments in Microsoft Foundry, you're equipped to improve agent behavior confidently, scaling generative AI systems that remain consistent, reliable, and production ready as teams, use cases, and expectations grow. Thanks for joining us for this session. To continue your learning, watch other videos in this course, or explore more in Microsoft Learn at aka.ms/learn.